March 6, 1944, 28,000 feet above Berlin, the sky shimmered with vapor trails and gunfire. The 56th Fighter Group roared into battle against the Luftwaffe in what would become the largest air fight ever witnessed over Europe. But something extraordinary was happening. German pilots, confident in their old escape tactic, pulled into steep climbs, expecting to leave the heavy American Thunderbolts behind as always. Yet this time, the Americans stayed on their tails. At the edge of stall speed, at the ceiling of the sky, Thunderbolt guns flashed, and black smoke spiraled down from stricken Messerschmitts and Focke-Wulfs. The 56th returned home that day without a single loss. The difference wasn't luck. It was engineering. The secret lay not in the engine or the guns, but in something deceptively simple: the propeller. Months earlier, in the brutal winter of 1943, American engineers had confronted a mystery. The P-47 Thunderbolt's massive Pratt Whitney R-2800 engine produced 2,000 horsepower. Yet the aircraft climbed like a stone. Combat reports flooded in from Europe. German fighters dove, attacked, then escaped by climbing away. The Thunderbolt pilots could only watch as their prey vanished skyward. Something had to change. At Republic Aviation's headquarters in Farmingdale, Long Island, engineer Alexander Kartveli studied the data with growing concern. Every climb test told the same story. The P-47 was powerful but inefficient. The culprit was the narrow-blade Curtiss electric propeller that sliced through the air beautifully at high speed, but failed to bite during low-speed climbs. The result? Wasted power, screaming engines, and lost lives. Kartveli and his team knew what they needed: larger blades that could grab more air, but making that work safely would require a complete redesign. Two American companies rose to the challenge: Curtiss-Wright, maker of the original propeller, and Hamilton Standard, a rival known for innovation. Each raced against time, sketching, cutting, and testing blade after blade through the cold months of 1943. Hamilton's engineers came up with something radical: wide, paddle-shaped blades that looked crude but behaved like oars in the air, generating immense thrust at low speed. Curtiss responded with a more traditional design, but with a larger surface area and smoother airflow at the hub. Both were brilliant, but only real-world testing could decide. By April 1943, prototypes were ready. At Wright Field in Ohio and Republic's own airstrip, test pilots put the new propellers through their paces. The results were stunning. Climb rates shot up. The Thunderbolt, once sluggish, now surged skyward with new life. Neither design had clear superiority, so the Army made a bold decision: approve both. Hamilton Standard props would be fitted to new Thunderbolts, while Curtiss models would retrofit those already in service overseas. The goal was simple: get them into combat fast. By the end of December 1943, the first paddleblade Thunderbolts reached England. Mechanics at RAF Wittering and Boxted worked through freezing nights, replacing old propellers one by one. When the 56th Fighter Group's commander, Lieutenant Colonel Hubert Zemke, took his upgraded squadron into the air, he immediately felt the difference. The heavy P-47 now climbed like a fighter half its weight. Zemke saw the potential instantly: new tactics, new possibilities. He trained his men to fight vertically, to spiral upward after enemies instead of breaking away. The Thunderbolt had found its wings. January 4, 1944. The 56th Fighter Group flew its first full mission with the new paddle blades. For the first time, they could chase the Luftwaffe into the clouds and win. German pilots, stunned by what they saw, reported that the Americans must be flying a new type of aircraft. But gun camera footage told the truth. These were the same old Thunderbolts, now transformed by engineering brilliance. The real test came 2 months later, on March 6th. Over Berlin, German fighters attacked the incoming bombers and tried their signature climbing escape. It didn't work. The Thunderbolts followed them up, matching every move, every climb. When the smoke cleared, 11 German fighters were destroyed. Not one Thunderbolt was lost, and not a single bomber in their care was shot down. It was the day the Luftwaffe realized the balance had shifted. Back in Germany, engineers studied wreckage from downed Thunderbolts and were baffled by the new propeller design. At first, they dismissed it, assuming it was only meant for takeoff efficiency. By the time they realized the truth, that it had fundamentally changed the Thunderbolt's combat capability, it was too late. The Allies had already deployed thousands. Through February and March, squadron after squadron converted to paddle-blade P-47s. German pilots who once escaped easily now found themselves trapped. Standard escape climbs became suicide maneuvers. On February 21st, a Luftwaffe unit lost 7 aircraft in one battle to the 56th. Their commander wrote in despair, "Every pilot who tried to climb was shot down." The Germans tried to change tactics, advising disengagement through level flight. But habits forged in survival were hard to break. During Big Week in February 1944, as American bombers struck German aircraft factories, the new Thunderbolts proved their worth. Over 3,600 escort sorties were flown. German losses mounted to more than 350 fighters. American losses? Barely 24. The Luftwaffe was bleeding out. Major Francis Gabby Gabreski, the ace of the 61st Fighter Squadron, became one of the greatest proponents of the new Thunderbolt tactics. He perfected the climbing spiral, a deadly dance that trapped German fighters into following him upward until they stalled. Then he dived back down and finished them off. Nearly all of his 28 kills came after the paddle blades were introduced. In his words, the Thunderbolt finally did what we always wanted it to do. Behind this success was America's unmatched industrial might. In just 9 months, 2 companies designed, tested, and mass-produced thousands of propellers. Factories worked around the clock. Each 650-pound assembly was shipped across the Atlantic, installed in England, and kept flying. It was a masterpiece of logistics as much as engineering. By summer 1944, the Thunderbolt's transformation was complete. Pilots had refined tactics for every situation, climbing spirals, vertical scissors, even new ground attack techniques. The wide blade props allowed heavily loaded P-47s to climb faster, even with bombs and rockets attached. They could hit ground targets, pull up sharply, and escape flak before the enemy could react. Between April and September 1944, Thunderbolts flew more than 88,000 ground attack missions, with less than 1% losses. As D-Day approached, the P-47 became a symbol of Allied dominance. On June 6, 1944, paddle-blade Thunderbolts roared over Normandy, protecting the invasion from above. The Luftwaffe barely appeared, less than 100 sorties all day, while the Allies flew over 8,000. Air supremacy had been achieved, and the humble paddle-blade propeller had played its quiet but crucial role. Statistics told the story. Before the new propeller, American fighters held a kill ratio of less than 2-to-1. By the summer of 1944, it soared above 4-to-1. The P-47 Thunderbolt, once mocked as overweight and underperforming, was now one of the deadliest aircraft in the sky. Even German aces admitted their respect. Major Günther Röhl, one of Germany's top pilots, later said that the upgraded Thunderbolt had to be treated like a Mustang. It could fight us in every direction. That respect was earned not by design perfection, but by adaptability. The Americans didn't wait for ideal solutions. They built what worked, fast. By the time jets began to dominate the skies, most paddle-blade Thunderbolts were scrapped or sold. Their contribution faded into history, but their legacy remains. They proved that sometimes the most decisive innovations aren't glamorous inventions. They're practical improvements, born from urgency and executed with precision. The paddle-blade propeller didn't win the war alone, but it gave Allied pilots the edge they needed when it mattered most. It turned the Thunderbolt from a struggling heavyweight into a champion of the skies, paving the way for victory over Europe. Behind that transformation was the quiet brilliance of engineers who understood that in war, speed of innovation can be just as deadly as firepower.